Good morning, everyone. Thanks for joining us on this introductory webinar to the OCS I/O. It's roughly about 20 minutes, and if you have any questions, we can get to those at the end.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. So today we have a webinar for our new OCS I/O series. So first we'll look at what is OCS I/O, and then we'll show you a short video showing you how everything goes together. Then we'll look in depth at the OCS I/O technical details, and we'll also have some video demonstrations. Then we'll talk about what the future holds for OCS I/O. Finally, we'll finish with a Q&A session to answer any questions that you may have. So what is OCS I/O? OCS I/O is a new family of expansion and remote I/O. Here, expansion I/O is any I/O we consider that is added inside the control panel, and remote I/O is any I/O that's located away from where the CPU is located. The new OCS I/O can perform both functions. OCS I/O is a new ground-up design. We worked with another vendor on the mechanical package, however all the electronics, the firmware, the software, etc., everything else is 100% Horner designed. With OCS I/O you have an I/O system that is fully integrated with our application software CsCAN and with our controllers. Now we'll show you a short video showing you how the OCS I/O looks and how everything fits together. So here's the OCS I/O. OCS I/O is modular, and it's built upon an innovative mechanical package and contains all brand new Horner designed electronics. You build OCS I/O from the DIN rail forward. Here a unique backplane connector is included with every module, and you pre-assemble those before snapping them on the rail. Once those are in place, it's simply a matter of installing the base in the I/O modules using the rail as your pivot point. Let's take a closer look at the base module, which is the first component in the stack. The primary function of the base module is to provide the connection to the OCS, which is plug and play from a wiring standpoint. The first commercially available base is the CNX. It features Horner's CsCAN network, but utilizes standard patch cables for network in and network out. That means straightforward daisy chain wiring. At the top of its housing, the CNX base has LEDs to show its connection status. You'll also notice LEDs dedicated to I/O status as well. That's because the CNX offers a few local I/O points of its own. The local I/O includes a new Horner innovation called flexible inputs, which we'll look at shortly. Here at the bottom of the housing is where the CNX power and I/O connections are made. The CNX accepts a wide range DC power input, so it is compatible with both 12 volt and 24 volt DC power. Now let's take a closer look at the CNX local I/O. The terminals marked 1A, B and C are the landing points for a 16-bit universal analog input, for example thermocouple, RTD, or high-resolution 0 to 10 volt or 4 to 20 milliamp inputs. Q1 and Q2 are solid-state DC digital outputs at 2 amps each. The AQ terminal is where you would land wiring for a single analog output. Terminals I1 and I2 are flexible inputs. When used as a digital input, you can configure them for 5 volts, 12 volts and 24 volt levels, or you can set custom on and off voltage thresholds. But the flexible inputs can also be used as 12-bit analog inputs supporting 0 to 10 volts and 4 to 20 milliamp signals. You can have up to 8 modules including the CNX base. In the first round of modules, there's a good selection of digital and analog modules to choose from, as well as AC input module for retrofits and a high current relay output module for those larger loads. And of course, you're not limited to a single base. With OCS I/O, there's capacity for up to 16 bases full of I/O, so you can expand to your I/O requirements. If you ever need to replace a module in the middle of the stack, you can just unlatch it from the rail and replace it. So now let's start looking at some technical details of OCS I/O. First, let's talk about where it fits in the Horner product line. OCS I/O is designed so that it works well with any of our product lines, whether that's an entry-level product like the Micro OCS or our higher-end controllers like the XL Prime series, for instance. When it comes to a small system on the Micro OCS, for example, the mix of I/O built into the base can often be all you need to complete your application. And of course, because of the fact that you can have up to 16 bases full of modules, OCS I/O does scale up well, making it a good choice for a larger system too. For the technical details, as we showed in the video, starting with the base, the connection with the OCS is based on CsCAN, and we are using RJ45 type connectors here. And what that does is it makes wiring, especially inside the control panel, a lot simpler. The backplane connector is also a nice feature. Modules snap together from side to side, but when you install and uninstall modules, you can uninstall them from the middle or any other point just by lifting the module off the DIN rail straight out. As we talked about in the video, you have built-in I/O in the CNX base and the flexible inputs, which are those two input bits that you can use for either digital or analog. So if you have a need for more analog in your system, you could get up to 3 additional analog inputs and 1 analog output out of that base. The two flexible inputs are 12 bits in resolution, and the universal analog input is 16 bits in resolution, and of course you have your 12-bit analog output as well. The two DC outputs are a robust 2 amps each. Now let's look at the configuration of those flexible inputs. Here you can select between the voltage range you're looking for, 5, 12 or 24, or you can select a custom range and specify your own voltage thresholds as well. Again, there will be plenty of micro OCS systems that will just need to add the base. However, it's also suitable for larger systems as mentioned, as the capacity is significant. So you can have up to 8 modules in a rack including the base, and a single OCS controller can configure up to 16 total racks. Because the base does have I/O built in, it does count as a module. We currently have 6 modules available in addition to the base, as well as several more in development. So now let's look at those 6 modules. The first module is a DIQ616. That is an 8-point DC input, 8-point DC output card, which on the input side is compatible with both 12 volt and 24 volt systems. It can be used in both positive or negative logic systems. On the output side, you get half amp 24 volt outputs that are positive logic in 2 groups of 4. We've also got a mixed module that is DC in and relay out. This has 4 DC inputs and 4 relay outputs. On the output side, it supports up to 3 amps maximum at 120 volts. All the relays are isolated. However, the way we've pinned the module out with duplicate terminals for both sides of the contact, it makes it easy to distribute your commons and connect the module to the field terminal strip efficiently. So again, there's a lot of extra terminals on board for the purposes of making a signal distribution simple. We also have a dedicated 4-channel relay output card that has a higher current capacity. So it supports more voltage up to 240 volts AC, but it also supports up to 8 amps per point AC or 5 amps per point DC with a total not to exceed 16 amps. All the relays are isolated, and once again we have duplicated all the contacts to make it easy to distribute your signals. For the environmental ratings in general, all the modules are rated from -40 to +60 degrees Celsius, with the exception of this module, which is limited to +50 degrees Celsius because of its current capacity. The next available module is an AC input module. So this is an 8-point AC input card where you can support up to 120 volt AC on one common. Again, we pinned it out to make it easy to distribute your signals and connect to your field terminal strips. There is one thing to note, which is that all your AC inputs do need to be on the same phase. The next module is our universal analog input module. So this is a module that has 4 inputs where each input is selectable channel for channel between voltage, current, millivolt, thermocouple and RTD. So this can be very versatile. If you need a couple of channels between 4 to 20 milliamp, a thermocouple and a millivolt signal for instance, you can accomplish that with a single card. As well as that, there's 16-bit resolution on the voltage, the current and the millivolt. It's actually higher resolution than that for thermocouples and RTDs. But what's reported for temperature signals, of course, is in actual degrees Celsius increments. Then on the analog output side, we have a 4-channel module, as well selectable between 4 to 20 milliamps and 0 to 10 volts. We also include support from -10 to +10, which is still in heavy use for applications involving motion. When it comes to connecting multiple bases together, we're again using modular RJ45 connectors. So when going from base to base, especially inside the same cabinet, you're just using standard Ethernet style patch cables. If an OCS I/O base is last in the network chain, then we have a termination plug that plugs into the empty spot on the last base. If you're using it with the micro OCS, the micro OCS only has a single RJ45 connector for CAN, but it also does have a software option from the system menu and from logic. So you can enable the termination resistor that's internal on the micro OCS. Not all Horner OCS controllers use modular jacks for CAN. A lot of our products, including the new XL Prime series, use traditional open style double plug for CAN. So it's actually quite easy to take a modular cable and to make a connection with an open connector. You really just need 3 conductors, CAN high, CAN low, and the common terminal, and standard cables are available or can be easily built. Next, let's look at the connector details. The I/O terminals are all spring clamp style, and they're also all removable, and all positions are labeled. They support cables between 0.25 and 2.5 millimeters squared. There's a small difference in the current capacity, but for the higher current relay module, we do use slightly larger blocks in terms of current capacity. When you go to eject the plugs from the module, for that you use a medium-sized flathead screwdriver, insert it through the orange eject tab and into the metal base as shown on the screen, and then pull straight down on that orange eject tab and all the terminals will eject at once. As mentioned, you can remove modules from the middle of a base without pulling everything apart. The mechanical package is designed to support what's known as hot swapping, or in other words, pulling a module out from the front while powered up. Now when you do that, the modules on the left of the remove module will work as normal, and the modules on the right will pause until the new module is reinserted. Even though it is designed for hot swapping, when you remove a module from the front, it's not designed to pull the backplane connectors apart while powered. Now we'll do a quick demonstration showing you how that hot swapping looks. So here is the module that we want to connect. So first we pull down here. Then for the module we want to replace, we'll just pull down and lift to unlatch it from the rail. And then we'll replace it with the other module. After hot swapping the modules, we can see here that the network is stable again with the replacement module. Looking at some other specifications, you can use either 10 or 24 volt levels with the OCS I/O. The voltage range, as you can see, is 9 to 30 volts. As mentioned previously, it has a wide temperature range of -40 degrees to +60 degrees Celsius with a standard product, with the exception of the high current relay output module, which is limited to 50 degrees Celsius instead of 60. Environmentally, it's designed to go inside of a control enclosure, so it's only IP20 rated or a NEMA Type 1. All the CE ratings are complete, and the UL certification is currently pending. From a CsCAN configuration standpoint, you will need CsCAN 9.9 Service Pack 8 in order to configure OCS I/O, and that is currently available on our website. The configuration is very similar to SmartRail, but with more features and enhancements. When you go to configure your base, the CNX can support really any combination of modules, so you don't need to worry about overpowering the I/O base with your selection. One of the enhancements with OCS I/O versus SmartRail, for example, is that if you're online with CsCAN and the OCS is connected to the OCS I/O base, then you can hit an auto populate button and it will automatically populate all the modules that are physically connected. We'll be demonstrating that feature shortly. Now we'll take a quick look at the OCS I/O configuration in CsCAN. You'll notice that there's something called the device UUID, and that's printed on the label. Generally, it doesn't come into play unless you have a system that has more than one base. Of course, we can support either the register-based configuration or the variable-based configurations that are required in both variable-based advanced ladder or in our IEC options within CsCAN. On the right, we're showing some of the details for the built-in I/O in the base, where you can configure the inputs for the universal input and for the flexible inputs. So there's a variety of different settings there for that built-in I/O. The next thing we'll highlight is the fact that you don't have to necessarily fix the sensor types or the analog types for your configuration in CsCAN. You can assign variables and then you can select, for instance, whether you're using an RTD type or a thermocouple type or a 4 to 20 milliamp type, etc. You could do that from the screen by creating a screen that accesses those variables, and then you don't have to make any changes in CsCAN if you want to ship machines that support different types of sensors. So that's another enhancement to OCS I/O. Now we'll quickly demonstrate how that auto populate feature works, and then we'll do some configuration. So first we'll go to the hardware configuration and then into the CsCAN I/O. Then we'll hit add and then hit OCS I/O. Then we'll select our base which we have connected, and then we hit this auto populate all button, and then we'll hit yes. Once that's complete, it shows us the device UUID, and then when we go back out, you will see here that it has automatically populated all the modules that we have physically connected. Then we'll do a bit of configuration. I'll go into config, then I'll input my registers. First, I'll input a status register of R1000. Then I'll input the start registers for my digital inputs, digital outputs, analog inputs, and analog outputs. Then I'll go out of that and I'll go into more info. And here you can see all the modules I have physically connected with their associated registers. Now let's take a quick look at where OCS I/O is headed in the future. We went through the modules that will be available at launch, which are the CNX base plus 6 types of I/O modules. However, we have several more modules that are also in development that you'll see in the future, including a high-speed counter module, higher density 16-point digital modules, as well as higher density 8-channel analog modules. Then we are also developing a module that has a mix of digital and analog signals that might give you the mix you need for your application. That concludes our webinar. Thank you for joining me for today's tutorial, and the Q&A session will begin shortly.
Okay, a nice drop into the OCS I/O there. Next week we do have a more in-depth look at the OCS I/O base. So the registration link is up for that on the webinar page on the website, which you should be able to see on my screen now. And as usual, if there's any past webinars you want to go back on, there's a full list of them here, or you can enter the keyword and it'll come up for you. I'm not seeing any questions as yet, so we'll take it as nice and straightforward for you. Okay, other than that, thank you all for joining us this morning, and we hope to see you again next week. Have a good day.